Hi, we are Team 48.
The Humanitarian Engineering Scholars second years, and over the last 24 hours, we have designed and built our own HES-themed Bop-It reaction game. As we graduate from the Humanitarian Engineering Scholars program, we wanted to create something fun and memorable as a gift for our president who has supported our cohort for the past 2 years. So, we built a custom Bop-It-style reaction game inspired by the program and designed entirely with our own hardware and code. Reaction games like Bop-It are popular because they force players to process instructions and respond quickly under pressure. We thought it would be interesting to explore how a game like that actually works internally and see if we could recreate the experience ourselves during this 24-hour Makeathon. Since we wanted it to reflect the Humanitarian Engineering Scholars, we designed the game as a custom HES-themed version where players must react to different commands using the controls on the device. Our game is controlled by a microcontroller that runs the main program and game logic. When the game starts, the system randomly generates commands for the player. Each command corresponds to a different physical action on the device. For our game, the player needs to react and pick between pressing the OSU button, bop it, and between lifting a gear, pulling a gear, flicking a gear, and twisting a gear. If the player reacts correctly and quickly enough, the game continues. If they miss the command or take too long, the game ends and restarts. As the player progresses, the speed increases, making it more challenging to keep up with the commands. This creates a fast-paced reaction challenge, similar to classic Bop-It gameplay, but with our own custom hardware and programming. To build this project in just 24 hours, we had to work across several areas. On the electronic side, we designed the hardware layout and wiring, programmed the game logic and timing system, and tested the gameplay to make sure the controls felt responsive and intuitive. On the mechanical side, we had to iteratively design components, check dimensions and tolerances to ensure correct fabrication of parts, and work with electrical to make sure our casing and mechanical components would function together effectively. This required combining electronics, programming, and user interaction design to create a system that responds to player input. Like most Makeathon projects, we ran into some challenges along the way. One of the biggest hurdles was getting the hardware inputs and software timing to work together reliably so the system could detect player actions consistently. Through testing and debugging, we refined the code and input detection, which helped make the gameplay smoother and more responsive. Overall, this project gave us the opportunity to explore how reaction games work, how hardware and software interact, and how we could build something meaningful to our Scholars program in a short amount of time. We're excited to talk more about our design choices, development process, and what we learned during the Makeathon, and we'd be happy to answer any questions. Thank you for watching.